Well, here's another example.
Shut up and start talking.
Okay, I will. Examine for relative extrema and saddle points, and then sketch. Like I say, I wouldn't expect you to sketch it, but I can do it with a fancy software. Might take a moment at this time. You can usually find 3D graphers on the internet, so you could look at these pictures on your own. So here's our function. F of xy is 120x plus 120y minus x times y minus x squared minus y squared. So the partial with respect to x, negative 120, minus y, minus 2x. And the partial of this with respect to y is 120, minus x, minus 2y. And solving simultaneously, see, we want both of these partials to be 0, or undefined, but since they're polynomials in two variables, there's no place where they're undefined, so we want them both to be 0, so we can find if we have a critical point. And if we solve simultaneously, I guess this would be y plus 2x equals 120, and this one would be x plus 2y equals 120, and if we solve that simultaneously, I assume we know how to do that, but just in case you don't, an easy way would be to solve this equation for y. See, y equals 120 minus 2x, and then take that and put that into the other equation, x plus y equals 120. But if y equals this, then we'd have x plus 2 times this 120 minus x. Oh, sorry. There, that's what I wanted to do. And say that equals, what is it, 120. And so if we work on this to solve it, we would get negative 3x equals negative 120, so x equals 40. And if x equals 40 and we put that back in here, we see that y equals 40 also. Now the other question is, why do I know that the critical point is x is 40, y is 40, and z is 4800? Because f of 40 is 120 times 40, that's 4800, plus another 4800, so I guess we're up to 9600, minus 1600, that's 40 times 40, minus 1600 minus 1600, so we get 9600 minus 4800, which is 4800. That's where that came from. So let's look at the second partials. Second partial of this with respect to x is just negative 2. Second partial of this one with respect to y is also negative 2. And the mixed partial, we could look at this one. Partial of this with respect to y is negative 1. Or we could have looked at this one. The partial of this one with respect to x is negative 1. And so now we're ready to check out D. So second partial with respect to x, negative 2, times second partial with respect to y, negative 2, so that's 4, minus the mixed partial squared, so we got 4 minus 1, and that's positive. And our second partial with respect to x was negative, so the point must be, this point right here must be a relative maximum, and here we can see a picture of it. You won't be expected to draw these, right? But at the point where x is 40 and y is 40, and well, z is 4800, you can probably see, maybe it'll look better if I connect it up a little better. You can see that there's a maximum point somewhere in this vicinity, right? X is 40, y is 40. There's a maximum point for the graph there.